Today we are looking at solving linear inequalities. That is solving things that have the less than, greater than, all of those symbols. A note, when you are solving inequalities, you need to get the variable to the left side. You always want it to be x is greater than something, or x is less than something, or greater than or equal to, less than or equal to. You don't want number, symbol, and then x. You want the x to be on the left. All right, let's just dive right in. Example 1, 2x plus 3 is greater than 9. We're going to treat this the same as an equation. What would you do first? Subtract 3. So 2x is greater than 6. We would divide by 2 to get our answer of x is greater than 3. Okay, now these number lines have a lot of dashes on them. You do not have to fill in all of these dashes. If you just want to put in like 0, 1, 2, 3, honestly, if you just stuck a 3 on one of those dashes, I would call that good. Okay, x is greater than. First, we have to talk about open circle or closed circle. If we are using these symbols that do not have the equal sign, we use an open circle. If we are using less than, equal to, or greater than equal to, we are going to use a filled in circle. The open circle means we are not including that number in the solutions. A closed in circle means we are also including that number. So greater than or equal to, we are including the number that we're talking about. Just greater than 3, we are not going to include 3. We're going to shade everything past 3, but not including 3. So open circle at 3. Greater than is the numbers bigger than 3, so we would shade this way. Excuse me. And do you remember the tip from your teachers that the greater than sign actually makes an arrow showing you which way to shade? Okay, the next one. What would we do first? Subtract 5. Negative 2x is less than or equal to 20. Notice when you subtract the 5, that is still a negative 2x. How do we get rid of the negative 2? Do you guys remember what happens when you divide an inequality by a negative? The symbol flips. So our next step will be x is greater than or equal to negative 10. Okay, I'm going to pick a spot to put negative 10. I honestly don't care where it is. If you want to put another number or two on there, you can, but I really don't care how detailed your graphs are. Closed circle at 10, and we're going to shade to the right. When I'm doing this on paper, I really like using highlighters because I feel like it's a lot easier to shade on a number line with a highlighter. So if you want to do that on paper, feel free to. On EdSite, you're going to actually get a cute little graph, and you'll have to click a thing and then move the points, and yeah. A compound inequality consists of two inequalities connected by the word and or the word or. And inequalities actually mean this. 0 is less than or equal to x, and x is less than 4. So this means that x needs to be bigger than 0. So 0, 1, 2, 3, but then x has to be smaller than 4, so we're only using numbers up to 4. We like to write that as 0 is less than or equal to x is less than 4. When you write an and inequality, it is always the smaller number, less than symbols, and then the bigger number. Remember, the alligator has to eat the bigger number, so the numbers to the right have to be bigger. X is going to be bigger than the smallest number, and x is going to be smaller than the biggest number, so we're constantly eating the numbers to the right. Okay, graph the following compound inequality. We do need -2 and 0 on this number line, so -2, -1. Actually, I'm going to do every other. I'm going to make this -1 and then make this one 0. Just to space it out a little. You don't have to if you don't want to. Okay, y is the shaded stuff. -2 is our first boundary, and that one has a plain less than. So this less than symbol, that doesn't want to erase, is going to tell us open circle. The less than or equal to is going to give us a closed circle. So open circle at -2, closed circle at 0, and y is in the middle, so we shade in the middle. When we're solving, we're basically going to think of this as a 3-piece inequality. There's 3 chunks. There's the left chunk, the middle chunk, and the right chunk. Whatever you do in the middle to get x by itself, you have to also do on the left and the right. So whatever you do in one place, you have to do in all 3 places. So if we wanted to get this x in the middle by itself, we need to get rid of the +1. We're going to subtract 1 on all 3 sides. So -3 less than 3x less than 3. Well, this one's going to be easy. Next step, divide. We are dividing by a positive, so we don't flip the signs. -1 is less than x is less than 1. And again, I'm going to space mine out a little bit and put -1 and then skip 1 and then 0 and then skip 1 and then, oops, +1. Open circles or closed circles? Open on both? And if you want to, on paper, if you want to put the circles above the number line, you can. I've seen this done before too. Some of you like it to look a little bit cleaner instead of like scribbling. You can definitely do that. Okay, number 5. What should we do first? This is 3 minus x or -x plus 3. This is a +3. We need to subtract 3. That gives us -10 is less than -x is less than 2. How do we get rid of the negative in the middle? Divide by -1. Warning, we divided by a negative, so we need to change those symbols. So we need this to be 10 is greater than x is greater than -2. Okay, now I tried to put this little reminder nice and big in the notes. Smaller number on the left, larger number on the right. Does this answer look correct? No, we need the smaller number on the left, the bigger number on the right. Really, we're just going to take that statement and we're going to mirror it. We're going to flip it around. So if you can visually see that whole thing just kind of floating around and then going backwards. But some people need to think about in between the -2 and the x. Right here, in between the -2 and the x, the symbol is eating the x. So symbol eating the x. Between the x and the 10, the symbol is eating the 10. So make sure that you get those flipped back around into less than symbols. So that is our final compound inequality. And now to graph it, -2, 0, 1, 2, 3, 4, 5, 6, 7, 8. We don't have room. So -2, we'll make this 0, 2, 4, 6, 8. There would be 10. Open circles. Filled in the middle. Next, we have OR inequalities. And the biggest thing that I want you to know about OR inequalities is that you still have to solve both of them. I've had students in the past see x minus 4 is less than 3 or 2x is greater than 18. And they interpret that as, oh, I can just pick one. So they pick the easier looking one and they leave the other one untouched. OR does not mean pick one. OR means that x has two ranges of numbers that it could be, and we have to find both of those ranges. So this is a two-part problem that we just happen to put on the same graph. So our first one, x minus 4 is less than 3. We add 4 to both sides. We get x is less than 7. That's the first part of our answer. The other side, we're going to divide by 2 to get x is greater than 9. So our actual solution is x is less than 7 or x is greater than 9. These are the types of graphs that have two pieces that point in opposite directions. So I'm going to put 7 somewhere on here. I'm going to put 9 somewhere. Oops, yep, that's the correct way. For a minute, I thought I was dealing with negatives. Open circle on both. X is less than 7. That means we shade left from the 7. X is greater than 9, so we shade to the right from the 9. I want you to try number 7 on your own. Pause the video, try number 7 on your own. So on number 7, you're dividing by negatives for both of those inequalities, so both of the symbols flip. Now, a lot of teachers would say, you need to put the smallest one, you need to put the less than one on the left. So our final answer is x is less than -6 or x is greater than -4. If you skip that step, that's totally fine. I don't care what order you put those inequalities, but I do care that you graph it correctly. So -6 is somewhere down here. I'm going to go by 2's, so there's -4. If you don't switch this around, you might be tempted to put -4 on the left and -6 on the right, and that would be wrong. So it is kind of nice to think for a minute. Which one is smaller? Make sure that one goes on the left. We have less than, so open circles, shade to the left, shade to the right. A good rule of thumb is if you are doing OR inequalities and you end up graphing it, and this one goes this way, and the other one goes this way, and they run into each other, you probably did something wrong. So if you know it's an OR inequality and your graphs start running into each other, you might want to go back and check because maybe you did something wrong.